Hi everyone and welcome to Statistics class. Today we are going to continue with the topic of probability. In the last class, we talked about the principal concept of probability and we saw some examples about that. Today we are going to continue with that examples, but right now we are going to calculate some probabilities. Remember, here as you can see we have the most basic formula to calculate a probability, that's some event. Then we have the 5 axioms that we talked about in the last class, and today we are going to calculate the probability through the fundamental counting principle. That is something new that you are going to learn today in events with replacement and with events without replacement. So, events with replacement. Example, calculate the probability of roll a dice 3 times and get only even point each time. My question is, what is the experiment? The experiment will be roll 1, 2, and 3 a dice. Second question, how many events are we going to have? We are going to have 3 events, 1 per each roll of a dice. Okay. To calculate the probability that the sentence is asking me, I'm going to make a diagram. That diagram will be called tree diagram. The first thing that you need to do is to write the numbers of events that you're going to have. For example, event number 1, event number 2, and event number 3. Okay, so each part is going to represent one part of the diagram. Okay, so now we're going to start over here in one point, and let's talk about that. Look at this. Here we have 6 different answers. We can have 3 odd numbers like 1, 3, and 5, that one, or 3 even numbers like 2, 3, and 6. So in the first event I have only 2 options. I can get or even number or odd number. Okay, this is the first thing that could happen at the first time that I'm gonna roll the dice. Okay, so what happened if at the beginning you got an even number? Well, you are gonna roll again. Okay, but if you have an odd number, you are gonna roll again too, so it doesn't matter. So the thing is that you are going to have at the second event, the possible result that you can have again will be that you can have again an even number or you can have an odd number. The same is going to happen over here. You can have an even number or you can have an odd number. Okay, so what happened in the third event? Okay, in the third event is going to happen the same. It doesn't matter if you have even odd, odd even, or odd odd. At the third time that you roll the die, you can have 2 options. You can have an even number or odd number, like this, like that one, like here, and like here. So you can have again even, you can have odd. So here you can have even, or you can have odd, you can have even, or you can have odd, you can have even, or you can have odd. Alright? Okay, the next thing that I need to do after make the diagram of the tree is to write the probabilities. Remember, probability, as I show you in an easy way, is the number of favorable outcomes over the total number of possible outcomes. Remember, check the first event. How many even numbers I can get at the first time that I throw the die? Okay, let me show you. There you are, 3. 3 of how many? Of 6. 3 of 6. What about odd numbers? How many odd numbers do we have in a dice? We have 3 of 6. Okay? So at the second time, the probability is going to change? The answer is not. It's going to be the same. Even as you can see, 3, 6, it's the equivalence of 1/2. And here is 1/2. Okay? So at the second event, the probabilities are not going to change. The probabilities will be the same, because let's suppose that I have even number at the first event. At the second event, I'm gonna roll it again. So my question is, how many even numbers do we have in the second event, at the second time that I rolled it? I'm going to continue to have it 3 of 6, and odd, I'm going to have 3 of 6 also. So it's going to be 1/2 and 1/2, 1/2 and 1/2, right? What happened over here? So the probability is going to be the same. The probability is going to be repeated each time. 1 middle, 1 middle, 1 middle, 1 middle. Okay? Very good. So what are you going to do right now? Here we are going to have results that represent the all possible probabilities of the sample space. This is the sample space. Each branch of the tree is going to represent the total sample space. Look at this. This part, like a way, we're going to have even, even, even. But in that way, we're going to have even, even, odd. Here, we're going to have even, odd, even, and then even, odd, odd. Here, we're going to have odd, even, even, then odd, even, odd, then odd, odd, even, and finally odd, odd, odd. Okay? This is going to represent the sample space. Well, it depends on the problem. This is going to represent the sample space. Now, the thing that we need to do is to calculate the probabilities. And how this is going to be very easy. Just multiply the even, even, even probability. Okay? For example, in the first one, it's going to be 1 middle times 1 middle times 1 middle. So you are going to have 1/8. So the probability here is going to be 1/8. So how much is going to be the probability about the even, even, odd? In that case, it's going to be 1/8(2), because the probability will be the same. Here is even, odd, even. It's going to be 1/8. Even, odd, odd. 1/8, 1/8, 1/8, 1/8, and 1/8. Okay? How to know that our sample space is okay? And in implicit form, the probabilities. Because if you add all the probabilities of each event, different event of all the experiment, you will have 1. 1/8 plus 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 1/8, you are going to have 8/8. So in that case, the addition is going to be 1. Even for each range, even for each event, you will have 1. For example, here 1 middle and 1 middle will be 1. 1 middle and 1 middle, 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 1. 1/8. 8 times is 1. So in that case, we are applying the probability axioms. that say that the addition of all the probabilities of the odd events always will be 1. Okay, let's remember what our example is telling us, or is asking us. It said calculate the probability of a roll a dice 3 times and get only even points each time. So in that case, I need to know that this is going to be the first answer that I want to have at the first event, then the second should be even 2, and the third should be even 2. So my answer is going to be 1/8. So the answer of this problem is the probability to have 3 even numbers will be 1/8. That is, as you can see, 0.125, or if you want to say 12.5%. And other important thing, why it's an event with replacement. This is an event with replacement because 2 important things that I'm going to show you right now. Question: why the events are with replacement? The answer is very easy. It is because the probabilities on the events don't change. What I'm telling about that is very easy. At the beginning, in the first event, the probability to have an event number is 1/2. As you can see, all the even numbers still being 1/2. The same happened with the odd numbers. Here in the odd number, the probability is 1/2, and all the probability to have an odd number still being 1/2. When the probabilities of of each event are not going to change, in that case we can say that the events are with replacement. Okay, so in other hand, it's because if I have 6 possible answers over here, so the next one I'm going to have the same 6 possible answers, and the next one I'm going to have the 6 possible answers. So the probability of a die never is going to change. Okay, let's explain the example number 2, and you are going to understand better, because we are going to see the events with no replacement. Events with no replacement. Example: calculate the probability of choose random 2 cards and get 1 with a diamond and 1 with a heart. Again, we are going to work with cards. Here we have a pack of cards. So my first question is, what is the experiment? The experiment will be choose random 2 cards of the pack of cards. Second question, how many events are we going to have over here? The answer is going to be 1, 2, 2, 1 per each card. Third question, what is the sample space? Well, that question I'm gonna answer, but at the end of this example, because here we need to calculate the probability, and then it will be part of the answer. Okay, so the sample space will be part of the how to calculate the probability. So again, we are going to make tree diagram, we are going to be using like auxiliary, and the first thing that we need to do is to write how many events we are going to have. In that case, we are going to have only 2 events. Okay, I'm going to make a line to separate the event number 1 of the event number 2. Next one is that I'm going to start over here, just in the middle. Okay, so look at this. Here, the thing that is involved is the type of card. Remember, we have cards with spades, we have cards with hearts, we have cards with clubs, and we have cards with diamonds. According with my sentence, I need to choose with diamond and hearts. Okay, in that case, well, my question is, if I scramble my cards and I get one, what kind of card can I get in the first one? So the question is going to be very easy. You can have 4 different kind of cards. You can have, for one way, a heart. You can have a diamond. You can have a spade, or you can have a club. Okay, those are the 4 options that you have at the beginning. So this one could be whatever of these 3. Sorry, whatever of these 4. Okay, so the question is, what happened in the other one? Okay, look at this. I choose one and I have only these cards, and I'm going to choose another one. The question is, what kind of card could be this one? Okay, again, we can have heart, diamond, spade, or club. If the first one was heart, it could be heart the second one, it could be diamond the second one, it could be spade the second one, or it could be club. Alright, if the first one was diamond, I'm sure that the second one could be heart, or could be diamond, or could be spade, or could be club. What happened over here? Okay, if the first one was spade, I'm sure that the second one could be heart, could be diamond, could be spade, or could be club. Okay, let me erase over here because I'm not going to have enough space. That's one thing that kind of complicates the 3 diagrams. Okay, that's one important thing that we need to take in account. Okay, about the space in the 3 diagrams. Okay, there you are. Okay, you can see it better. Okay, if the first one was a club, I'm sure that you can have in the second one, you can have a heart, you can have a diamond, you can have a spade, or even you can have a club. Okay, and this is my 3 diagram. So let's see the sample space. Look at this. In this case, with this branch and that one, we're going to have heart, heart. In the second one, we're going to have heart, diamond. Here is heart, spade, and here is heart and club. Here we're going to have diamond, heart, diamond, 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 spade, and diamond, club. Here is going to be spade, heart, spade, diamond, spade, spade, and spade, club. And finally, here is club, heart, club, diamond, club, spade, and clap, clap. Okay, maybe you cannot see the last part, but I'm going to show you. Okay, let's move the zoom of the camera. Okay, now it's better. Okay, right now, as you can see, we can see the sample space, but let me show you something. Here we have some repetitions, and it's important that you consider to reduce the sample space, because, for example, well, here we have heart and heart. Okay, this is going to be part of the sample space, is going to be called P, or pack of cards. Okay, okay, this one, heart, heart. Do we have another heart, heart? No, we don't. We don't have. So I'm going to write heart, heart, comma. Now, what about HD? Do we have another HD? Well, in that order, not. But here we have the H. This one and this one will be exactly the same, and this is not going to be repeated in any other one, so the other one will be HD. Okay, what about HS? Do we have another one? Yes, over here, SH, but those are the same. Okay, so in that case we are going to have HS. Finally, we have HC. Do we have another one? Yes, CH. HC and CH will be the same, so I'm going to write HC, just one. Okay, what about DH? Well, we already got it. What about DD? We are not going to have another DD. What about DS? We have another one, SD. So DS, okay, and SD will be the same. DZ, let's see, here we have CD, so this is another one. DC, okay, got it. SS, are we going to have another SS? No, SS is other one. SC, do we have another one? Yes, SC and CS is going to be the same one. And finally, CC. This is the sample space. Okay, as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different events on our experiment. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different results. But you can reduce it because some results will be the same. So you can reduce it, and at the end, this is going to be the sample space. Okay? Well, the thing is that the example said that we need to calculate a probability. So this is the second part that we need to do after make the tree diagram. And it's not necessary to make the diagram always, but I'm going to show you later. For now, let's make the tree diagram. Okay, so let's see what happened over here. If I choose a heart, remember how many hearts, how many cards with heart do you have? In that case, remember that we have 52. 13 of one, 13 of the other one, 13 of the other one, and 13. Okay, so from heart, I'm going to have 13 cards with hearts of 52 cards. How many diamonds I'm going to have? I'm going to have 13 cards with diamonds of 52. Now here, how many spades I'm going to have? I have 13 spades of 52. And how many clubs? I'm going to have 13 clubs of 52. Okay, if you add 13 over 52 plus 13 over 52 plus 13 over 52 plus 13 over 52, you will have the summatory is going to be 1. So it means that event number 1 is right in my tree diagram. Okay? Now let's continue over here. Look at this. In this case, the events are called with no replacement. Why? Because look at this. I have a card, okay? And according with this one, the first one should be a heart. Let me like that one, okay? Okay. This is the first one, and it was a heart, okay? It was a heart. So my question is, I'm going to take the second one. The question is, how many hearts I'm going to have over here? Here, I'm not going to have 13 anymore because I choose one. So it means that the second one will be 12 of how many cards do we have over here? Here, I don't have 52 because I choose one. And I didn't put it again on the pack. I just let it over here. So I'm going to have 51. Do you understand? Here it changed. It changed what? The numbers of hearts and the number of total cards. What about diamonds? I haven't chosen any diamond. So in that case, I still having 13 diamonds. But I just have 51 cards. Alright? Because I took one. So in spades, I'm going to have 13 of 51, and on clubs, I'm going to have 13 of 51. Alright? So this is the for the first branch. Let's talk about the second branch. In the second branch, it's supposed that I'm going to have a diamond. Let me look for a diamond, okay? Here. This is the first one. First event is a diamond. Okay. Second one. In the second one, my question is, how many hearts do we have over here? We have 13 hearts available. How many cards do we have over here? 52. Okay? Because with this one is 52, no, 51. Alright? Because with this one, 51 plus this one is 52. Now let's continue with this one. Diamond again. How many diamonds do we have if I took one? So instead to have 13, I'm going to have 12 of 51 cards. Now how many spades do we have over here? We have 13 of 51 cards. And how many clubs? We are going to have 13 of 51. Do you understand? It was for the second branch. For the third branch, now we're going to select a spade. Okay? Okay, it was here. It was the first one, is one spade. So let's continue with the second event. How many hearts do we have over here? I have 13 of how many cards? 51. How many diamonds? 13 of how many cards? 51. How many spades do we have over here? I took one, so it means that I have 12 of how many cards? 51. How many clubs do we have over here? I have 13 of how many cards? 51. Okay, and finally, as you can see, this is going to be repeated, but not all the cases is going to be the same. It depends on the problem. Later we're going to see different kind of problems. Okay, this is just for introduction, and the last one is going to be a club. Okay, there we go. I got a club. How many hearts do we have over here? We have 13 of how many cards? 51. How many diamonds? 13 of how much cards? 51. How many spades? 13 of how many cards? 51. How many clubs over here? I took one. We have 12 of how many cards? 51. Okay, and I finish. As you can see, that number are the same that number, but with this one move it. Okay, and this one and this one. So the thing is that I need to calculate I'm going to calculate those probability over here, okay, with addition, through the addition. 12 over 51, sorry, 12 over 51 plus 3 times 13 over 51. Okay, how much is that? Is 1. So if we add this probability that are the same like that one, I'm going to have 1. Here is the same, 1. Here is the same, 1. So it means that my tree diagram, it's okay in the second event. So the only thing that I need to do is calculate the probabilities on each part of this. Okay, how? Very easy. Just multiplicate the probabilities of each branch. For example, this time this time this. Let's do it. This is going to be 13 over 52 times 12 over 51. In that case, let me show you. In that case, it's going to be 1/17. In that case, is 1/17. We have something similar like that one. For example, here is going to be 1/17, and here 1/17, and here 1/17. 13 over 52 times 1 over 12. Sorry, 12 over 51. Okay, like that one. Very good. Okay, let's continue. Now I'm going to multiply this times this. This is going to be 13 over 52 times 13, sorry, times 13 over 51. Okay, how much is that? It will be 13 over 204. Okay, as you can see, the other one will be the same because we have 13 over 52 times 13 over 51. Okay, so the only thing that I'm going to do is to copy 13 over 204, 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 again, just one more, and that's it. So how to know that I'm okay? Very easy. Just add all the probabilities that you have over here. It's going to be very easy. It's not necessary that you add one by one. Look at this. How many 1 over 17 do you have? You have 1, 2, 3, 4. Okay, 4 times 1 over 17. There you are. Okay, plus how many 13 over 204 do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus 12 times 13 over 204. Are you ready? How much is that? That is 1. So it means that we are right. Okay, our tree diagram is right. So here, the question number 3 was answered. What is the sample space? The sample space was or is this one. Okay, but the question, the original question was, let me show you it. Calculate the probability of choose random 2 cards and get one with a diamond and one with a heart. So it means that I need to calculate the probability of, let me show you, diamond and heart. So of this one, diamond and heart, or heart and diamond. Right? So let's see where we can have that one. In that case is this. Alright? And that's that one. This and this. That's right. So here is heart and diamond, and here is diamond and heart. Look at this. It said one with a diamond and one with a heart, but it doesn't say it in that order. It just said one and one. So it means it could be heart and diamond or diamond and heart. This is another important thing that we need to pay attention with the problem, but in this case it doesn't matter. So the probability that HD happened, okay, right here, HD or DH, because it's the same in that case, is going to be very easy. Just add both probabilities. 13 over 204 multiplying by 2, because it appeared twice. Alright, and in that case it's going to have 13 over 102. That is approximately equal to 0.1274, or if you rather, you can say that it's going to be 12.74%, and this is the answer of the second example. So before we finish this example, and to explain what is the difference of the event with no replacement and with the replacement, I want that you remember something about the last class. In the last class, this is the last class. In the last class, the problem was choose random 3 cards and get one with a diamond, one with a heart, and one with a spade. We tried 10 times and we never got that one. Okay, the question is why? Why we never got that one? Well, because it's impossible? Now the answer is not. It is possible, but maybe the probability is going to be very, very low probability. Look at this. In that case, it was just 12.74%, and I can do it. I can do it 5 times. I'm going to show you. Look at this. I'm gonna scrabble it. First 1 and 2. Okay, diamond and heart. I have it at the first time. Okay, I'm gonna do it again. Okay. Okay. Here again, and here again. No. Okay, the second one was not. Okay, let's do it again for the third time. I'm gonna show you. Heart, very good. And spade, no. Another time. Okay. Let's see. The 5th time. Sorry, 4th time. No. And obviously not. Okay. Well, the thing is, I have a 12.74% of probability that it happens. That one. So my question is, the probability here maybe is going to be very slow. So that's why in the 10 times I didn't get. In that case, I just made 4 times and I got the first one. You know? So this is the interesting thing about the probability. The probability is going to give you a number. Okay? But the probability means that maybe it's going to happen, maybe it's not going to happen. It's going to give you a number that's going to indicate the occurrence of the chance that you have that happens. Okay? Later in other class, I'm going to solve this problem. But just for now, I want that you understand how to calculate the probability through the 3 diagrams, okay, with different events. Now, what is the difference with events with no replacement and events with replacement, like in the other example? Well, it is very, very easy. I'm going to write over here events with not replacement. The principal characteristic is that the probabilities change. As you can see, here the probability was 13/52, and here change, here and here and here and here. The probability change. And in the other example about the dices that I'm going to show you, with replacement, the probability didn't change. It keeps the same. And this is very, very easy to understand. Not replacement means that I'm going to get one element for the first event, and then in the second event I'm not going to take in account the first one. I'm just going to take in account this one. Okay? So if I have, for example, other event, at the third event I'm just going to have not 51. I'm going to have only 50 cards because those are out of that one. So that's why it's called not replacement. Okay? Sometimes happens that, for example, first event, okay, I took this one, but I'm going to put it and I'm going to scroll it and I'm going to choose the second one, and then I'm going to put it over here. As you can see, we have exactly the same cards. Okay, so the same chances. In that case, it's going to be an event with replace. In that case, it's impossible. For like the cards, if you roll the dice, all right, so you have 6 chances. The second roll, you will still having 6 chances. Third roll, you still having 6 chances. Probability is not going to change. Okay, first event, I have 52 cards for the first event. For the second event, I have 51. For the third event, I have 50. For the fourth event, I have 49, and etc. This is the difference of events with no replacement and events with replacement. Okay, I hope you understand what is the difference between that two probably cases and how did I use the probability basic formula and the axioms of the probability. Okay, that's all for today. So in the next class we are going to continue with other examples when we are going to use events with replacement and events without replacement, and we are going to do this example, but not with a tree diagram. We are going to use the fundamental counting principle that we already use over here, but is not necessary to make a tree diagram if you know how the fundamental counting principle works.